Okay, so our next speaker is going to be Mauro, and he will speak on towards automated threat elicitation from the AI Act. It seems that this presentation is slightly different from what we discussed so far. So let's. I'm looking forward to see what Mauro wants to present. Please go ahead.
Hello everyone. So the most difficult part in presenting is to deal with the tools. So I'm Mauro. I'm a PhD student at MIT School Lucca and the University of Catania. And today I'll be presenting our joint work with Simone and Giampaolo. So the main idea is that in literature we have threat modeling methodologies that are usually carried out manually. And of course, to optimize these kind of tasks, we want to proceed with automation. But another challenge is, a main challenge is to deal with threat modeling from multi-domain regulations to ensure also legal compliance. So if you are not familiar with threat modeling, essentially it's the process of analyzing, identifying, and evaluating threats. And in this specific context of dealing with regulations, the objective is to extract threats that come from regulatory text documents, for example, the GDPR or maybe the AI Act, as it is the case of this work. So in general, the manual extraction of these requirements, threats, also assets from this kind of legalist texts is slow and also error prone. So we want to take an approach that kind of enhance automation, but still requires a little bit of human intervention, as we shall see in a bit, in order to have an approach that combines human and artificial intelligence to automate threat elicitation. And in our work, we apply this approach to the AI Act. So first we'll have an introduction, an overview on the methodology, then we will discuss about the application on the AI Act. We'll talk about the validation of the results, and then we'll conclude the presentation. So in a nutshell, we can divide the methodology into two main phases. We have asset extraction and then threat elicitation. We start from an input document, which can be, of course, various kind of documents, legal documents, requirements, and we want to extract from this document some threats. So in the first phase, asset extraction, we can identify some other steps. The main steps are non-extraction using SPACY, which is a Python module, embedding plus the application of the algorithm K-means for clustering. We then filter and merge clusters and leverage an LLM to refine the results. Then for the threat elicitation phase, we'll split the articles, the documents by articles. So if you think about the AI Act, you have different articles in the text. And of course, for performance reasons and also to deal better with the data, it is convenient to split it into articles. So think about sections. We'll have an extraction carried out by the LLM, and then we first perform within article merging, so a merge of the threads identified within the same article, and then a global merging to reduce redundancy among the results. So more in the details. The first phase, asset extraction, this is also an approach that is used by threat modeling methodologies that are called asset-oriented. So we first focus on assets, on a system, on a document in this case, and then starting from this analysis, we elicit the threats that may affect those assets. So the asset extraction phase is based on natural language processing, clustering, and also carries out an LLM-based refinement. We first employ a spacing noun extraction, then we employ word embeddings, k-means, to cluster the assets that are similar together, and then we refine the results with the help of an LLM. So for the noun extraction, essentially it's quite basic. So you given a sentence, in this case a sentence from the text of the AI Act, you can extract the nouns, so organization, integrity, personal data, for example, from this sentence. Then we compute the embeddings for each noun and run k-means. And here a little bit of intervention from the human analyst is needed to choose the optimal k for running k-means via series score. From our experiments, we identified k equal to 3 as a multi-band k. Then we essentially proceed with the refinement by the LLM. So here the analyst also intervenes into setting a threshold for semantic similarity. So semantic similarity, essentially, as the name suggests, wants to capture the how to threads in this case, but in general, sentences are similarly near semantically. So in our experiments, we found some threshold that would be useful, but I'll talk about it later. Then we filter the assets that are denounced, that are averagely below the similarity that the analyst sets. And then we merge the assets if we have that the clusters within the clusters if the cosine similarity is above the threshold that the analyst chose. We then run an LLM to select the assets basically from all of this preprocessing, let's say, with a system prompt. Then, after we extract the assets, so we carry out this pipeline from the legal text, the document, we can essentially split the document into articles. The human analyst chooses an n, so an integer basically that defines how many runs we want to do with the LLM to extract the assets, because one of the main challenges with LLM is that non-determinism that is inherent to LLMs. So we want to try to converge into an optimal results by running the LLMs multiple times and take a summary of the results. So we extract the pairs thread assets, so the thread that can affect the asset for each article. Then we consolidate the results, so we carry out a merging within the article with another prompt, so we try to reduce redundancy within the same article, and then we perform a global merging to merge all of the articles, so the threads identified in the articles. So, for example, to give you an idea, here are some of the threads that can be extracted from the text. For example, for article 1, we have 3 threads that are extracted, and then after the global merging, we carry out just one thread that tries to summarize all of the threads that we identified in the previous step. So we decided to apply this methodology to the AI Act for its relevancy nowadays, of course, and just to give you some ideas, we carried out several runs to identify some optimal threshold values that could work better with the AI Act in this case, of course. So one of the challenge here is, of course, to objectively identify which is the proper threshold to select. This, of course, depends on the text that you want to analyze. these are some examples of thresholds that we tried. So, for example, for the detection of the threats, for the similarity, the semantic similarity, and for the merge similarity, the global merging. And here are also some performance comparison of the runs. We have essentially the number of extracted assets and the macro clusters that are gathered and compared with the cohesions of the semantically cohesion that is within the cluster of the assets. So we want to select, of course, a cluster that gives you a good amount of assets, but that cannot clusters that give you a good amount of assets, but with a semantic similarity that is, of course, coherent. Here we have a sample of the extracted assets from the Act. So these are essentially the nouns that are some of the nouns that are identified by our pipeline. And in general, we extracted a total of 38 AI-related threats from the AI Act. So in our system prompts to the LLM, we also ask to give an explanation of the threat that is carried out as output to have the analyst and also the reader in general to better evaluate the quality of the results. So here, for example, we have some threats that recall AI misuse, discrimination and bias, lack of transparency, privacy violation, and adversarial attacks targeting AI. This threat list, this threat catalog that we extracted with our methodology also goes beyond a technical catalog. So it can be, of course, useful from a threat modeling perspective for cybersecurity practitioners to better identify and prioritize the threats that can affect AI systems. But we can also identify some examples that resonate with the AI Act itself. So as a confirmation that these threats have been extracted from a legal text in that case. So, for example, we have the privacy violation, which is a threat quite general, resonates with Articles 10 and 11. Discrimination and bias reflects Article 10 and also recital 44 and so on. So, one of the challenges in threat modeling in general is how do you pilot and evaluate also results, because sometimes we don't have a ground truth to compare with, as a baseline. So in this case, we take a questionnaire approach, so which is quite also common. So we ask to our cybersecurity and AI ethics friends if that we are all aware of these three facts, and we ask essentially how relevant they find the following threats with respect to those facts. So essentially, we employed a Google form to try to validate our results. So we ask the respondents on a likelihood scale, so starting from 1 to 7, how they would agree on the quality of the threats. So these are the outcomes. As you can see, the outcomes are quite high. So you can see they are quite high on the likelihood scale. So it reflects the fact that the threats that we identified are essentially validated by the practitioners. So with some outliers, but we have to understand that the pipeline is quite is almost fully automated. Just in few cases, the analyst intervenes, and as of the limitation, of course, some of you maybe already spot some of the limitations. The threshold, of course, remains as a major issue because there is no objective way of finding the best way to determine the thresholds, but we can we try to mitigate these issues with multiple experimental runs, at least for the AI Act. So Another issue is that the LLMs are non-deterministic, so also here we employ multiple runs to converge on an optimal result. And generalization, of course, of the methodology is limited because we only employed it to apply it to the IACT. So for future work, we want to apply it to other legal and non-text. And of course, the validation has a limited set of respondents. We can extend it and also design and improve the question. So this concludes the presentation. Essentially, just as a summary, we defined an HAI-powered threat elicitation methodology that leverages natural language processing and LLMs. We elicited a total of 38 AI-related threats from the AI Act, and future work is quite self-explanatory. So we want to go further with applying to other regulatory frameworks. We want to also explore LLM fine-tuning to improve the LLM capabilities on our methodology, and try to expand the validation of the results. So with this, I thank you for listening and for the question.
And any questions?
Thank you for the clear and nice presentation. I really like the approach. I'm interested in your design of the first part, so the asset allocation. How did you come up with the idea of extracting nouns and your justification for that? So I'm wondering, then there is an importance of also other words, like if you imagine there was like an example sentence, if you have if there is not shall ensure, but for example must or must not or anything, that must also be important for the input.
Yes, so the answer I can give you is that essentially nouns are typically related to assets. So assets in threat modeling are usually the elements that you want to protect, right? So essentially elements are nouns in general, so that is the reason why we focus particularly on that. I hope that answers. But yes, of course, let's say a more complex analysis of the sentence will be also carried out by leveraging more on the LLM, but we wanted first to focus on just NLP because of the non-determinism and hallucination of LLMs, so that's the reason. But basically assets are usually nouns.
Yeah, thanks.
Thank you. Any other questions? Okay, one question from me. So you extracted asset and threats from the AI and then try to validate it using human or maybe experts. So have you thought about to validate, just to identify is there any gaps in terms of asset and threats in the current AI legislation? Have you thought about to validate them, let's say comparing to the other kind of threat metrics? For example, Meter has produced AI threat metrics, and also you can extract maybe from the various academic papers and following a similar approach. Let's say you extract potential asset and threat from other sources, and then to compare these two, just to identify what are the missing.
Yes, so essentially, yes, Micro has carried out a catalog of AI threats. So we essentially want to focus here on just one regulatory text, and the aim was to understand how we could leverage automation on threat modeling. Of course, also for the sake of validation, would be future work to compare against the Micro attack, and also I can speak about another methodology that is published on another journal. It essentially tries to leverage different sources, so it also follows the reasoning that you just mentioned. So build a complete thread catalog from different sources. But of course, in that you have to deal with redundancy because, of course, you could deal with some threads that we extracted, for example, that are also present, but in a different with different terminology, maybe in Imagine, and then you have to also employ maybe semantic similarity to consolidate the results. But that's an interesting.
Yeah, I think that's a bit challenging, but it should be interesting to identify if there are any gaps in the current legislation covering in terms of asset and threats. Okay. If no more questions, perhaps you can thanks once again for this.